All right, this is an application for the forces, the magnetic forces. And here we have a particle with charge. The Q is negative 5.60 nanocoulombs, moving in a uniform magnetic field, and the magnetic field is described by 1.25 Tesla. It's along the positive z-axis. The magnetic force, it's given negative 3.40 10 to the negative 7 in newtons, I plus 7.40 10 to the negative j. Okay, here we should have in newtons also. Calculate all the components of the velocity of the particle that you can from this information. All right, then the first part, it is like I have, let's, a drawing is going to be very helpful. This is X, this is Y, and this is Z. Now, when the magnetic field is along the positive Z, then it is out of the, then it's out. But if this is my positive, then this is gonna be out of the page. And the force, it is along the plane that contains both I and J. Then it's like somewhere here. Okay, like it's hard to draw that three-dimensional. All right, now what I can do is here I can say F equals Q V cross B, and as I said, please review the cross product. And then here this is gonna be Q, and this is I, J, K, and that is Vx, Vy, Vz, and this is Bx, By, Bz. Okay, and then here I can say that this is gonna be the case I, J, K. Okay, I just, these are not known. I need to calculate these. And Bx is 0, By is 0, and here I have negative 1.25. Therefore, okay, when I perform the cross product, I'm gonna get the following: negative 1.25 Vy minus 0. This is for the I component. For the J, is gonna be negative 1.25 Vx minus 0 J. And for the K, we are going to have 0. And that actually, I can make it simplify to negative Q 1.25 Vy I plus Q 1.2 Vy Vx 1.25 Vx times J. Also, known information here is that F is negative 3.40 10 to the negative 7 newtons I plus 7.40 10 to the negative 7 in newtons J. If I compare this with the one that I got from the cross product, I have here negative Q 1.25 Vy I plus Q 1.25 Vx J. Then I can, by comparing, I know that Q negative 1.25 Vy should equal negative 3.4 10 to the negative 7 newtons. And from that, I can calculate Vy as negative 3.4 10 to the negative 7 newtons divided by negative 5.6. This is the charge in coulombs. And then I will be able to calculate 0.486 10 to the 2 meters per second. This is for Vy. Then Vy is negative 48.6 meters per second. Then I was able here to calculate the Vx, the Vy, and also when I compare the x values, then I'm gonna get this, and I will use it for calculation of Vx. Also substituting in the value of Q. And from that, I will be able to calculate what is really the value of Vx. Now, of course, we know that Vz is 0. And this is answering the second question. Are there components of the velocity that are not determined by the measurement of the force? Explain. And here we know that, like from this measurements, Vz did not come out, does not contribute to the force, and therefore it is not determined by the measurement of force. Now also calculate the scalar product V times V times F. What is the angle between V and F? Also, this piece of information, this is from physics 201. These are perpendicular vectors, and we know that when we have two perpendicular vectors, when you cross, make a dot product, it should be 0. And I can do that and verify it. Okay, this is gonna be 0 since they are perpendicular. Because they are perpendicular to each other. Thank you, and then I'm gonna go over the rest of the chapter with you. Thank you.